So the second recording for this week, I'm going to focus a little bit more on linear regressions. I'll show you a little bit of stuff in Excel, but also just show you some output. So one thing for some of these projects, if you think that there's something you want to do and you don't know how to do it in Excel, I would still like for you to try to run some regressions in Excel. But if there's some things that you think you've seen in some of the papers we've talked about, for instance, one thing we'll look at today is like some fixed effects. It's gonna be very difficult to do that in Excel, and I can do that for you in a program called Stata, and then I can send you the results. So I'll show you some of what the results look like from Stata. It's very similar to the regression output we see in Excel, but that is an option for the projects. So just a reminder, and I walked through this in class a few times, but how do we add in that regression analysis tool package? So I go to File, and here's someone's data. I had a bunch of tennis data. A couple of you I've sent some of this. Go to File, go to Options, go to Add-ins, go to Manage the Excel Add-ins, hit the Analysis Tool Pack, and hit OK. Okay. Now, I know on Macs, I think the only difference is instead of going to File Options, there's like a Tools Options or a Tools Options at the top. And then once you hit that, it's like I've hit Options, and then everything should look pretty similar. You'll go to your add-ins, and under the Tools, there's an add-ins option. You go to Manage the add-ins, you'll select the Analysis Tool Pack. Okay. So that's just a friendly reminder. We can start to think about, I'll start to talk through this issue and look at the effect of spending money. I don't think that we've walked through this. If we have, it's just kind of set up. It's related to some other stuff I want to talk about. So I know if you've had me in 221, you've probably heard a little bit of this initial discussion, but bear with me. So let's say I wanted to estimate the effect of an additional dollar spent on the probability of making the NCAA tournament that should be going on right now that we've been deprived of, right? So I have this measure of basketball expenses, expenditures on a basketball program, and whether or not they made it into that very first round of the tournament, right? So 1 if they did, 0 if not. So the effect of beta 1 should be, it's a 1 unit increase on the x variable, so 1 more additional dollar spent on my basketball program would increase, and if I have a 1, 0 variable as my y or my dependent variable, you can think about what my coefficients interpretations are now. It's increases or decreases in the probability of seeing that 1 occur. Right? Because I go from 0, kind of going from 0 to 1, right? Those represent probability. So 1 more dollar spent on my basketball program increases the probability of making it into that first round of the NCAA tournament by whatever that beta 1 coefficient estimate is. Okay. So what would we expect to be? Well, if it's the effect of $1, it's probably going to be pretty small, and we would hope that if I spend more money, it's positive. So just kind of positive and small, it would make the most sense to that question. Well, we know that if we just look at a simple linear regression and we don't include additional controls, we can get some really weird estimates, right? So we call this the omitted variable bias. We're leaving out, or we're omitting important variables that are correlated with expenses that are really the ones driving the effect on making the tournament. It's not necessarily expensive, it's these other things that are correlated. So what's something where if I have larger basketball expenditures, I might also happen to be a larger school, and so maybe I want to capture that with using the total number of undergraduates at a school, right? So what do I think is going to happen to this coefficient? What's likely going to change, right? This expenditure was probably picking up some of maybe what just the overall size of the university was. Larger universities more likely to spend more on their basketball program, and maybe those expenditures didn't necessarily get put into recruiting or something like that. It's more of the infrastructure or the maintenance of that arena, because if I have more undergraduates, it's likely to have a higher attendance, and so maybe I'm picking up some of those effects, right? Now, we don't talk too much about kind of how we sign the omitted variable bias in this class, so it's okay, you won't be expected to know that. But what you should know is when I include additional control variables, it's likely that this is going to change, right? It's likely that my coefficient estimate is going to change from what it was when I just had no controls. Okay? So I actually did this, and it looks like the estimate is pretty small, right? It's the effect of $1, it should be. But one thing I can do is, well, if I know the effect of $1, right? Well, some of these teams are spending almost 23 million. So if the effect of $1 is 0.000000722, the effect of spending an additional, say, $1 million would be the effect of $1 times a million. Right? We're gonna treat most effects as linear for this class, or that's all I expect you to do on your project. And so if you know the effect of $1 to get the effect of a million, you simply multiply that coefficient estimate by a million. If I want to know the effect of 5 million additional dollars spent, take the effect of $1 more, multiply it by 5 million, so on and so forth. Okay. So we could do this for different programs and actually come up with some kind of interesting findings, which is if I look at the schools in the top 10, an average increase in their spending of 10%. So most of the average expenditures for their basketball program in the top 100 was about $10 million. And so a 10% increase would be about an additional million, right? It ends up being a little bit less than that, but so it wasn't exactly 10 million, it was like what, 9.35 million. So what would the effect for them be if they increased their budgets or increased their expenditures by 10% on their basketball program? Well, if the effect of $1 was 0.0000722, the effect of an additional 935,000, they'll just multiply that, right? And the increase in that probability of making it to the tournament is 0.0675, or a 6.75% increase in the percent, or in the likelihood of making the tournament. You could do this for other schools. So I did it for IU. They're kind of similar to the average school here, just a little bit. Their expenditures are a little bit higher. So a 10% increase in their budget would increase their probability of making the tournament by 8.6%. For Ball State, they're spending quite a bit less, so an increase in their budget of 10% is only $150,000. So if they increase their expenditures by 10%, they're only getting a 1.1% increase in their likelihood of making a tournament. We could do this for whatever school we could want. And I'll show you the Excel data here in just a second. It's on Canvas. It's the basketball regressions file, I think is what I call it. So what else might we want to control for? Well, it doesn't just matter how much we're spending on the program. There's a lot of other control variables we might want to include. So, well, how much am I making? Not just how much am I spending, how much am I making, my revenues. Well, what year is it? And in different years, maybe there's higher, lower demand for the or there's higher, lower overall quality in the league, and so maybe some years it's more or less likely for me to make it. Control for previous quality, like what the quality of the program is, so how many wins did they have the previous year? Did they make the tournament the previous year? So now, if we look at all these things, it looks like, well, now if I spend more money in my basketball program, instead of 0.00, whatever, all those zeros and 7, it falls to that same, I think it's the same number of zeros, but to 2. Right, so it's gotten quite a bit smaller. Still statistically significant. We said, how do we know if it's statistically significant? We have to look at this p-value, which here's my state output. Right? So it's a little bit different than the Excel output we're used to seeing, but here's my state output, and that effect of spending $1 more on my basketball program is statistically significant because my p-value is 0.001. So what we start out always assuming with these linear regressions, and this is kind of a little bit of a review, and I think we did this early on in the course, but this will help with kind of your regression analysis for your project. And also there may be a question or two on the final that we need to know this concept. So, what we're doing is we're finding a test statistic, we're finding, and here we always have a two-tailed test, we're finding our p-value. So what we're saying is we're assuming that's the statistic we're interested in, so this coefficient, we're assuming that it's always equal to 0. That whatever variable, whatever right-hand side variable we're looking at, we're always assuming that that coefficient is 0. Okay? So the only way we can reject that null is if our p-value is less than the alpha for whatever confidence level we want to say this at. So our alphas for the 99, 95, and 90% confidence levels, our alphas are 0.01, 0.05, and 0.1. Okay? So I only rejected my p-values less than alpha. Well, from that regression, I said the p-value we saw was 0.001. Well, that's going to be less than every single one, so we can reject the null at the 90, 95, 99% levels. And what was the null? The null was that there was no effect. So what we're saying is we can reject that there's no effect, or that we found strong evidence that there is in fact an effect from this variable. Okay, so so a little reduces our estimate a little bit because we now are controlling for more factors, right? And so expenses are no longer picking up some of the effects that came from these other things that we were omitting. Okay. Now, if you think about the effect of spending more money, well, if you know, we've got a couple things going on. Why might there be differences between D1 and D2 schools? Well, if we think about if I'm spending an additional dollar and I'm Duke, well, so let's say Duke is spending an additional $1 million on their basketball program. Well, they're already high quality. How much more can they really increase it? Well, we have the diminishing marginal returns, right? As I spend more money, the effect of each additional dollar spent becomes less and less. So I compare Ball State to Duke, and they both spent an additional $1 million. That additional $1 million is going to have a much stronger effect probably for Ball State than it would for Duke. So maybe I want to break this up, and I'll just break it up into D1, D2 schools, because there are a lot of D2 schools, and we're thinking about, right, what's the change in more money spent, or what effect is more money spent having on the probability of making it to the tournament. So what we're going to do is we're still going to have this expenses, but we want to know what's the additional impact that comes from spending more money for these D1 programs, right? And maybe it's negative, maybe it's positive. So what we do is we take that basketball expenditure variable and we interact it with an indicator for 1 if I'm at a D1 school, 0 if I'm not, right? So now I've got this indicator, right, for am I a Division I school? What's the additional impact that spending an additional dollar has? Well, what you can see is it's actually that estimate is negative, meaning that the positive effect that comes from spending an additional dollar doesn't have as large of an impact if I'm already a Division I large program, right? So that these D2 schools, the effect of an additional dollar spent is going to be much larger, right? And this is really because of diminishing marginal utility. They aren't spending as much money, so the effect of one more dollar for them, much higher effect than the effect of $1 for these large Division I programs. And it's not quite statistically significant, so we should be a little bit wary of that. But you can kind of see it change the estimate quite a bit, and we're not the furthest from significance here. Like I said, we're pretty far from. I guess we're pretty far from 0.1, but who knows? If we throw in some additional controls here, maybe we pick up some significance here. Okay? So we do the exact same thing, but instead of what's the effect of spending more money on making a tournament, we could make the y variable 1 if you were the national champion, 0 if not. So how does spending an additional dollar impact my probability of winning it all? Right? Well, it's an even smaller estimate, right? So we could say this is the effect of $1 more spent on my basketball program of increasing my probability on becoming the champion, national champion. So if I spent $1 million, it would be this effect times $1 million, which ends up only being like a 0.1% increase. So would that 0.1% increase be worth it? Well, if I had to spend an additional $1 million, it's only worth it if the expected value is higher. So if the amount of additional revenue I could generate by being the national champion times the expected, right, the probability increase in that, so 0.1, if that is greater than $1 million, then I should spend the $1 million. If it's not, I shouldn't, right? And so for a lot of these programs, it's likely not gonna be worth it. Right? So if Ball State kind of increased their budget by 10%, which was that $150,000, it only increased their chances not by 0.1% but 0.016%, right? So even if I increase my budget by 10%, my expenditure by 10%, I'm barely, changing that percent of becoming a national champion, right? And is it statistically significant? Well, if we look at this, in fact, pretty high p-value. So really, it's looking like there's no real effect of spending an additional dollar on the probability of winning national championship, unless if we look at the interaction term now, if I'm a Division I program, well, now spending additional dollars, there's an even greater effect that I win the national championship, right? And so that's statistically significant at the 90 and 95% levels because the p-value of 0.014 is less than our alpha of 0.05 and 0.1, but not at the 99% level because it's not less than 0.01. Okay. And once again, this is kind of state output. So we see that maybe having athletic success, it can be impacted by how much money I'm spending on the program. But there's a lot of pushback, that people don't like the fact that these large universities spend a lot on their athletic programs because they view it as though their funds are being taken away from other areas, right? And so, I don't know. I think in economics, a lot of the times, what's good to do is not focus on direct effects, but also think about indirect effects that could exist as well, right? Usually we have a pretty good idea about what the direct effects might be, but the indirect effects are also should be part of the decision-making process. So here, how might athletic success impact other things at the university or provide other benefits, such as academic quality, right? So, why might there be a link between these two? I think I mentioned this in a prior class, but if I have success in the NCAA tournament or in the college football playoff, right? Really, what that is, getting my name out there. It's really just marketing, right? It's just kind of it's getting my name out there to more people. It's really just marketing and potentially getting that increased exposure makes more people aware of my product or my university. Maybe I get an increase in the number of hits on my webpage, and then I get an increase because of that, an increase in number of applications I get. And if I have more applications, I can be a little bit more picky with what students I admit, and so maybe I can get an increase in my academic quality. Right? So it might sound like a pretty long kind of string of indirect, it was kind of this long path to get around how these two things are related, but let's actually look and see, maybe they are related, right? Maybe there is an effect of athletic success on academic quality. So I had some data that I played around with, and then we'll relate this to a paper that was done in 2014. So I'm interested in is the number of applications that a school gets, does that change if they made the tournament in the previous year? Right? So the idea being, if they made the NCAA tournament the previous year, does that in the fall, do they now see an increase in the applications that were sent to them in that year? So for that upcoming fall semester. So quite a few observations here. Include this 1-0 variable. Did they make the tournament or not in the year prior? And it looks like p-value of 0. This is statistically very significant. It looks like if I make the tournament in the previous year, I see an increase in my applications of about 7,000. Well, look, that seems pretty crazy. Maybe not, but I'm not controlling for anything else here. So that doesn't make sense, right? So what's one other thing I can control for that would be a pretty good predictor of what my applications will be this year? Well, I'm also going to include what the previous number of applications I was receiving was. Now, once I control for that, it's like saying, given that we had two schools that had the same number of previous applications, but one of them made the tournament last year, the effect of making the tournament would be an additional 101 applications. And it's not quite statistically significant right outside that range, but it's pretty close. Okay? Well, I might say, well, look, yeah, I'm controlling for the previous number of applications, but I'm still leaving out a lot here, right? So then I say, well, look, I know that there's going to be different applications in different states, or we have different populations across different states, and so maybe I want to control for what state that school is in, right? So if I control for what state the school is in, really what that's saying is, and these are numbers that represent, I don't even remember, this is Alabama, and this is Arkansas. So they're creating indicator variables. So just like when we talked about that earlier paper where it took that contract length variable and it created a bunch of different indicators for, was it a contract length of 2? Was it a contract length of 3? And if it was a 1. If it wasn't, it was a 0. We do the same thing. If we had a variable that had the state name, we're now going to create fixed effects where one of them is Alabama. 1 if the university was in Alabama, 0 if it wasn't. The next one, Arkansas. 1 if it was in Arkansas, 0 if not. We'll leave one of those states out to be our comparison state. But it now allows for our regression to be, given that we had two schools in the same state and had the same number of previous applications, now if they make the tournament, what's the increase in their expected applications? And here now we get an increase of about 167, and it's statistically significant at the 90 and 95% level, because that p-value is less than 0.1 and 0.05 are alphas. Now this is the one where it's a pretty easy command to do in Stata. In Excel, I'd have to create a bunch of different columns with the indicators, and equals, if this other variable is equal to California, put a 1, 0 if not. It takes a lot more time, right? It's a lot easier for me to do it, and I can do some of, if you do want some fixed effects for your project, let me know. I can run the regressions data for you and kind of get you the output in something like this, okay? That was just in the number of applications, right? So I've got some evidence that they're at least receiving more applications. If they're receiving more applications, they can do two things. They can either admit more students, or they can admit the same number but be pickier, right? They can be pickier with who they let in, potentially choosing, on average, higher quality students. Right? So, what's the effect of making the tournament previously, not just on applications, but what was the average incoming freshman's ACT score? So I didn't do the average here. I actually chose the 75th percentile. It's kind of more for data availability ease, but also thinking about, well, I'm just going with the average changes. I really want to know if I can pull that upper right tail up quite a bit, right? The upper end of my distribution. Sure enough, very statistically significant, right? P-value is basically 0. And it looks like making the tournament the previous year, holding constant the number of applications I got the previous year, I can increase my ACT 75th percentile by 1.5. Now I'm not including a lot of other controls here. It looks like similar effects also kind of for English. So how great is this effect? Well, I mean, the standard deviation is 3.5, so an increase of 1.5 is almost more than a third of an increase in a standard deviation increase, which is pretty big, right? So more than a third, it's pretty sizable effect, right? Now, obviously these regressions are far from perfect, right? There are many more control variables I could include, but this is at least a kind of initial kind of look and start. It's kind of interesting. And the data that I used, let's see if I have, I think I opened it up earlier, but if I didn't, I know that I have it in here. So let's go class basketball regression. So this is the one that's up on Canvas. So taking a second. So here's, I've got undergraduate enrollment. This is the one where I had basketball expenditures. Where is it? I've got revenue. Oh, here it is. Maybe. It's somewhere in here. There's their operating expenses. Here's revenue, participation. Well, this is the original data. I think then what did I do here? I broke it down. Here's the expenses, and this is kind of some of the what I use for the D1, D2 schools. Here's the original data. Like I said, usually what I do just to make it easier, I'll copy. Oh, here's the expenses squared, which is okay. So I usually copy this and like paste it on another sheet, get rid of the variables I don't need. So I did like that here. Right now I've only got expenses, I've got revenues, I've got the other things that we controlled for, and kind of played around with that to get to the regression results that I was showing you earlier. Okay? So I also kind of looked at. So yeah, here this tournament wins is the one that I was looking at. Here's the effect of making the tournament previously on undergraduate enrollment, but you could also look at including things like these SAT score measures. Now obviously I have a lot of missing, so I had to get rid of a lot of the missing variables. But this is the data set you could play around with to answer some of these questions. Now, this week's reading, right, is a similar idea. So it's by Pope and Pope. Sorry, it wasn't 2014, it was 2012. So Pope and Pope, they had this very similar idea where does NCAA tournament or NCAA football success increase SAT scores that are sent to these schools? So when you take the SAT, you could designate a certain number of schools to send it to for free, or as part of, not for free, as part of taking the SAT. And they said, okay, do schools get more of these SAT scores sent to them when they have tournament or football success? Right? So we'll go to that paper. Okay. And some pretty interesting kind of findings here. So let's go to the tables. So one thing that's interesting, like one thing that's nice is a lot of people kind of take the SAT like right around the time of basketball season ending, and so you know having the success here, we might see an increase in the SAT score percent. But if they took it earlier, then potentially it's the prior year's basketball success, right? Football season kind of ends here, so that might be a little bit better. Maybe the current year is the better measure for seeing if football success this year leads to kind of higher SAT scores in the fall. But basketball might have to be lagged because there's a large number of SAT scores being sent potentially here. Right, these deadlines right here are before the actual basketball season is complete, and we could see all the success that the team had. Okay? So, let's rotate this clockwise. So here was kind of the initial findings, right? So the y variable here is the log number of SAT scores. So like I said, we won't focus on using these natural logs. They have a slightly different interpretation, which is that this is going to be the effect not on the number of SAT scores sent, but the increase in the percent of SAT scores sent. But here I just want to focus on the direction. Right? I want to focus on the directional changes. So if they made it into those 64 teams that made it into the tournament, you can kind of see the effect was positive and statistically significant. The more success they had, right, going from the Sweet 16, Final Four, champion, looks like that effect grows, right? The more success I have, the effect on the number of SAT scores sent to my school increases. Same kind of idea for football. If I make the top 20, I'm in the top 10, and if I'm the champion. And they lag all these as well because of the timing issue that I kind of already mentioned. They control for a lot of things: school fixed effects, year fixed effects, school trends, other school controls. And so they're trying to compare otherwise equal universities, and so if one of them has success and the other doesn't, what would the increase in the number of, or the percent of SAT scores sent to them be? I mean, here, 0.09 is a 9% increase. That's pretty big. It looks like the effect really is concentrated. So even if I just look at making it into the tournament, the effect looks like it's there for males but not females, for sports fans, and kind of not really as strong for non-sports fans. But the real interesting one is here. It's not statistically significant for in-state students, but it's very statistically significant and larger in magnitude for out-of-state students. Specifically, if we look at higher levels of success, right? Now this has got to be really close statistically significant, but it's not quite. But you can kind of see the effects are larger here for the out-of-state schools. Also similarly for football as well. So the idea here being marketing is really, you can think maybe more successful if in some, in-state, people are probably already aware of your product. I always say, the example for the NCAA tournament, people in Indiana might know where Valparaiso is, or Valparaiso University, but someone in California likely has no clue that that's in Indiana. They don't even know it exists, right? And so the out-of-state ones, that's who's really getting exposed to, and you're increasing the knowledge that your product even exists. And so that's probably why we see an increase in the effect there for out-of-state as opposed to in-state students setting on their SAT scores. Kind of continue down. To break this down even more and kind of look at the lags, I don't want to focus on that one too much. If we look at kind of football success, they break these lags down too. This isn't the one I wanted. There's another interesting, there we go, counterclockwise. So one thing that is kind of interesting, if they look at the, not only did I kind of win in a certain championship and kind of lagging it, but look at the effect of close victories, right? So if I remember right, let's see how they define these close victories. Why did I think that they had demographic subgroups? Oh, we kind of look here at, so what we got, table 4 here. So table 4 shows how students respond to teams that barely win relative to teams that barely lose. Right? So this is in the NCAA tournament, looks like, in their whatever game that they were, kind of their last game. Right? So regression discontinuity produced by aggregating all rounds and plotting the seed and probability that the team makes to the following center tournament, the point difference in the current year's tournament game. So did they win that game? Did they lose? So the current year looks like there's no effect, and we talked about maybe it's because we need to be lagging this, right? So we look at the lagged effects here. So did I win the game? Was the margin less than 2 or less than 1? So this is a closer margin than this one is. And we kind of see the effects look like they're a little bit higher when it was a closer game. But also, another interesting is even if I was in that game and I lost, even though I lost, these like are still statistically significant. Now notice the effect is still a larger possible. So even if I'm in the game and I lose, I'm still getting an increase in SAT scores sent to me. But now, if it's a closer game, like that margin is less than a point as opposed to less than 2, the effect of even losing, it has a greater impact, right? So the effect, whether I win or lose, I'm benefiting here, right? And if it's a close game, I'm benefiting even more from winning, and I'm still benefiting even more even if I lose, right? So that was some of the really kind of interesting findings of this paper. They were able to include a lot more controls than some of this that I showed you. It wasn't just the number of applications, but it was these SAT scores being sent, so maybe a better indicator of actual interest. Kind of those two things go hand in hand. We just got a lot more practice and looks at how we interpret regression output. Like I said, I expect all of your papers to have some type of regression output. Maybe the exception of 1 or 2 of you in which you're still going to have a different type of data analysis that you can do, either comparing averages or running a t-test or something if we don't have as much data or as much data available for your topic to be able to run a regression. But I think most of you can, even if it's not ideal. We don't have a huge sample size. I think most of you should, at the very least, be able to run one. Maybe the results won't be as meaningful, but you can still kind of run the checklist, right? Do the interpretations of your coefficients, say whether or not you find them to be statistically significant, mention maybe some omitted variables that you wish you did have that you don't, things like that. So I'll put up some papers. I kind of gave you a nice little summary of the weekly reading, but I would suggest you kind of go through that a little bit more in detail. Like I said, I never expect you to kind of read through and understand all of it, but look and see what they wrote out for their regression equation or their empirical strategy. Also look at, read through the introduction, the conclusion. Try to be comfortable with at least the discussion I just had over the tables I pointed out. So tables 3 and I believe it was tables 2 and tables 4. Okay, so this is the second lecture. It's a little bit shorter, but it kind of just focused on some regression output, some additional topics. Hopefully this is helping with the projects. I should have all of the, a lot of you have the data for your project. A couple of you, I'm still putting some finishing touches on it. Hopefully you're working on the other portions of that paper though, your literature review, kind of the underlying economic principles for your project, and should be getting almost everyone, I think everyone should have their data by the end of the week, with the exception of some of you. I think I might have mentioned I can try to get you some additional variables, but at the very least you'll have something where you can start to do that data analysis. Okay. So I don't think there's anyone currently on the stream. So I was going to ask for any last second questions, but I'm not seeing anyone. I'll try to, like I did this week, I'll let you know when I'm going to be filming these. Next week should be a more similar schedule as the last 2, which I'll be live streaming on kind of Monday and on Tuesday in the afternoons. My other sections had a test this week, and so I kind of got them ready yesterday and had a lot of kind of WebEx, Skype, Zoom meetings individually, and saved today just for kind of filming for ECON 330 for you guys. Okay, so I'm going to end the recording here. If you have any questions over anything, please feel free to email me, and I should be getting you all kind of that data for your projects here shortly.